All right, here are notes for functions and domain and range. So what is a function? A function says for every output, which is the y, there is only one input, which is your x. Okay? And there's different ways that we can determine if it's a function, but the way we're going to look at it today is with the vertical line test. So you're going to run a vertical line left to right. If it only hits the graph once, it's a function. Okay, so let's figure out what that means. So if we look at this first graph, if I run a vertical line here, it's not going to touch the graph, doesn't matter. If I run a vertical line here, it's only going to touch the graph in one spot, so that's good. But as I move that vertical line along, here it's going to touch the graph in two spots, so that's a problem, so this is not a function. On the second one, it doesn't matter where I run the line. Yes, it's a function. Third one, run the line anywhere. Yes, it's a function. Okay? On the fourth one, the vertical line right here only hits one spot, but as soon as I move it over, it's two spots, so no, it's not a function. Okay, this next one's a little tricky. Right here, it's only hitting one spot. That's all good. Okay? But let's see what happens here. When I run it here, it looks like it hits two spots. But right here we have a closed circle, and that means it's everything up to that point and including that point. Okay? But here, it's got an open circle. It's everything up to that point, but not including that point. So this one includes it, and that one does not. So it's actually just included once. So yes, this one is a function as well. Okay? Over here, nothing, but we've got two spots. So no, it is not a function. All right, so now we need to figure out domain and range. So the domain is the set of all x values, and the range is the set of all y values. And we've got a couple different graphs that we're going to look at, and I'm kind of going to do them out of order. So we're going to start with this one. Okay, so for the domain is the set of all x values, so we're looking at the x's. So we're going to read the numbers off the x-axis, and we are going to write them, our answer, in interval notation. So if I'm looking at the x's, I start on the left. The graph starts at -5. It's got an open circle, so it does not include that point, so I'm going to put a parenthesis. The graph ends on the x at +5, but it's got a closed circle. It does include that point, so I'm going to have a bracket. My range is the set of all y values. You're always going to go from the bottom up. So the least point, the lowest value here, is -2. There are definitely points at -2, so I have the bracket. And then it goes all the way up to here. I'm reading the numbers off the y-axis because this is my x for the domain, y for range, and it goes up to +2. It includes that point, so I have a bracket. Let's slide over here and see what this one looks like. The domain is the x value, so I'm going to read it off the x-axis. Well, as I'm reading it, this one, even though it doesn't look like, it's actually getting wider in both ways. So it's going to go all the way to the left and all the way to the right. It's never going to stop. And because it's never going to go stop going left and right, we say it goes from -infinity to +infinity, because it just is going to keep getting wider and wider. It's going to get wider slowly, but it is going to keep getting wider and wider. The range is your y values. And again, because of the arrows, it's going to keep going up and keep going down. So it's always going to get smaller and it's always going to get bigger. So it includes everything. So it's -infinity to infinity. Now notice with the infinities that I wrote parentheses, because infinity is not an actual point on a graph. So it means everything up to. So it keeps going and going. All right, let's see what else we can look at. Let's try the domain on this one. Okay, So the domain is the set, the set of all x values. So as I go left to right, it's going to include all numbers. When it includes all numbers, my domain is negative infinity to infinity. The range is the y value. Well, it only crosses the y at one spot. It's just one point. It's not a range. So when it's just a point, we put these little symbols like that. I don't know what to call them. And then we have the 3. This is really what I'm trying to draw, even though those are not great. All right, let's look at the domain and range for this one. Now, what might be helpful, well, we can do it this way. Domain is the x values. These are not connected. Like this up here, this is a connected graph. These are not connected. So when we're listing the domain and range, we're just listing points. So when we list points, we don't put the parentheses or the bracket. We do that fancy thing, and then we're just going to list. But remember, the domain is the x. So the first x is -3, and then 2, and then 1 is right here, and then 2, and then 5. Then the range is the set of y values. We go from bottom to top when we do the range. So the bottommost y is -5, then 0, then 1, then 4. Okay, there are some more below this, but I want to go back and do this one, and then this video is done. You can get the rest in your notes. The domain on this one is, again, it's always going to be your x values. Okay, so we have an x value here at -3 and an x value here at 2. But there is nothing in between. So if we wrote it from -2 to 2, or from -2 to 2, it would indicate that it was all the values in between, but that's not what we want. We just want it as points. So when we want it as points, we've got these like squiggly things. So we've got -3 and +2. The range is the set of y values. Now we're looking at something different. We're looking at the y-axis. So we're going from bottom up. Well, it's always going down, and it's always going up, so it's going to include all the y's. So to include all the y's, you have negative infinity to infinity.